The antiderivative. This is exactly what you think it means. The derivative in reverse. So you're going to be given the derivative, and you're asked to find the original function. So what would have a derivative of 2x? I'm hoping you realize that's x squared. The derivative of x squared is 2x. The c is because the derivative of a number is just 0. So we could have had x squared plus 341. Derivative of 341 is just 0. You could have x squared minus 11. Derivative of minus 11 is just 0. So what we've done is we've given every possible answer for the function that has a derivative of 2x. Let's try another one. What has the derivative of 3x plus 5? If you look at what happened over here, the x became an x squared. So this is going to be a 3x squared. But then we're going to have to divide by 2, because when you take the derivative, you multiply by 2. A little bit tricky. What has the derivative of 5? Oh, 5x does. Derivative of 5x, you multiply by 1, and then we add the c. This is getting even harder. What has the derivative of 4x cubed? Can you think of that as x to the 4th? What has the derivative of x to the 4th? Something to do with x to the 5th. 2x squared would need something to do, not so obvious. So we're going to look at the power rule and see if we can get a rule so that we can do this again and it won't look quite so frightening. So going forwards, when you take the derivative of a number times x to an exponent, we multiply by the exponent and lower the power by 1. So going forwards, multiply by exponent, lower power by 1. So going backwards, raise power, divide by new exponent. Let's try that again. Going forwards, multiply by exponent, lower exponent by 1. Going backwards, raise exponent by 1, multiply by new exponent. You can see those will cancel out and we'll end up with what we started with. So let's try that rule with this, and maybe it won't be so frightening. So raise exponent by 1, divide by new exponent. Okay, exponent was 3, raise it by 1, divide by new exponent. Exponent was 4, now it's 5, divide by new exponent. Exponent was 1, now it's 2, divide by new exponent. Then reduce anything you can, that just becomes x squared. This just becomes x to the 4th. And make sure you add the c so you get every possible answer. Maybe that's not so bad. So the way you often see this rule, when you have a function in the form number x exponent, the antiderivative is found by raising the exponent by 1, dividing by the new exponent, and then adding c. So this rule is good when you have something in the form number x exponent. What if you don't? All right, what has a derivative of cosine? That's going to be one of the trig functions. Derivative of sine is cosine, so the antiderivative of cos is sine. Add c so that we get every single possible answer. Antiderivative of 1 over x. You might be tempted to write that as x to the negative 1. Raise the power, x to the 0, divide by 0. Okay, that's not good. So let's keep thinking. Is there something that has a derivative of 1 over x? Now, ln x has a derivative of 1 over x. So the antiderivative of 1x is ln absolute value of x. Now, why is that? What's happening here? This function, if you think of the domain, the only problem is x equals 0. So it exists for negatives and for positives. When you just have ln x without the absolute value bars, it only exists for positive numbers. So the reason we're putting the absolute value bars is so the domains of these two functions are the same. If you put absolute value bars around x, if x is negative, the ln of that still exists. And then add c so that we've answered all possible answers. Okay, the derivative is 1 over x to the 4. Let's try writing it in the form number x exponent. We can raise the exponent by 1 and divide by it. And then we'll clean that up. So x to the negative 3 becomes 1 over x cubed, and the negative goes on top. How do you tell the difference between this one and this one? Essentially, you're going to do the same thing every time. When you see an exponent on the bottom, make it negative. If it's in the form number x exponent, raise the power and divide by it. And as long as you're not dividing by 0, this is fine and it's going to work. You clean it up, x to the negative 3 becomes 1 over x cubed. The negative goes on top. And if we try that method over here, we'll notice we end up dividing by 0. 1 over x is x to the negative 1. Raise the power, x to the 0 divided by 0. So that tells you that this method does not work over here, and it lets you know that there must be another original function. That's how you're going to remember that the antiderivative of 1 over x is the ln of the absolute value of x. So how do you do antiderivatives? You think of all the rules that we had when we took derivatives. These were the rules going forwards. So now we just find the derivative on this side and go backwards. So when something is in the form number x exponent, you raise the power and divide by it. If it is not in this form, you look for it in the list. So if you see cosine, the antiderivative is sine. If you see minus sine, the antiderivative is cos. If you see secant squared, the antiderivative is tan. If you see 1 over x, the antiderivative, this is the only one you'd have to change. We'd be tempted to write ln x, and then we remember, oh, there's something about those domains, so we have to make it the absolute value of x. So I've written down all your rules as if we were going forwards, and you can use them going backwards. Just make sure you put absolute value bars around. So if you see the antiderivative e to the x, you'll know the answer is e to the x plus c. Let's see if that helps. So the antiderivative of 7x to the 5 plus 3x cubed plus 9x plus 3. It's in the form number x exponent. When it's in the form number x exponent, we raise the power and divide by it. So raise the power to 6, divide by 6. Raise the power to 4, divide by 4. Raise the power from 1 to 2, divide by 2. There are no x's here, so that's x to the exponent 0, raised to the power 1, divide by 1, which we tend not to see. And then nothing simplifies on this one, so make sure you've got your plus c, and that one's done. This one, the antiderivative is secant squared. Not in the form number x exponent, so now we're just looking for it. And there it is. Antiderivative secant squared is tan x. So the answer for that one, tan x plus c. There's going to be a part B to today's exercises. So part B, find the function which satisfies the given condition. All right. So we have the derivative. We're not sure what that means yet. We'll get to that later. So let's see if we can find the original function. Number x exponent. So that's where we get to raise the power and divide by it. Raise the power and divide by it and add c. Let's clean this up a bit. So the original function had to be 2x squared plus 3x plus c. Now the lovely thing about this section is you can check your work at any point in time. Take a derivative. Derivative of 2x squared is 4x plus 3. We know we're on the right track. Okay, time to deal with this. It says f of 2 is 8. So it's f of x. So that means x must be 2. So we're going to plug 2 in for all our x's. And what's this? F of x is another way of writing y, so y must be 8. So 8 goes in for f of x, 2 goes in for x, and we'll work that out. So 2 squared times 2, that's 8. 3 times 2 is 6. Get rid of the 8s, bring the 6 over, and we found out that c is minus 6. Why do you care? The function that we had originally, the 2x squared plus 3x plus c, can now be a very specific answer. And we'll just put negative 6 in for c. So what we've done is we've found the antiderivative of this function. And when we do that, we find all the curves that have this as its derivative. But we want the specific one that passes through 2, 8. And the specific one that does that has a negative 6 in for c. Let's try another one. Antiderivative of sine. All right, what has a derivative of sine? Got something to do with cos, and I find I get really confused with these plus or minus signs. So what I would do is I'd know it's got something to do with cos. take a derivative and then see if I'm right. Derivative of cos is negative sine, so that means we have to take the derivative of negative cos. So the two negatives will cancel each other out. Let's try that again. Take the derivative of negative cos. The answer would be negative sine, which gives us positive sine. F of x. So x is pi and y is 1. We'll put 1 in for y, pi in for x. Cosine of pi, that's negative 1. We get the negative of negative 1, which is 1. Bring that to the other side, and I think we'll find out that c equals 0. So instead of having a general solution to the antiderivative, we'll have a very specific one where c equals 0. And so that's our answer. Okay, your job today on page 1, you're doing part A 1 to 8 and part B 1 to 15. Again, as always, when you do something new, it's a little tricky at first, but the more you do, the easier it gets. So get yourself to work, and if you have any questions, let me know.